Welcome to The Explainer. Today we are diving deep into something called the Model Context Protocol, or MCP, and we're going beyond just the basics. We're going to talk about the standards, the governance, really the best practices you absolutely need to build reliable, production-grade AI integrations that can actually truly scale.
So let's just start with a problem that I know every developer, every product manager out there knows way too well. You've got this amazing, powerful AI model, but getting it to talk to the real world, to your APIs, your databases, your Jira board, that is a huge challenge, especially when you're trying to go from just a cool prototype to a real platform.
And you know what the result usually is? It's this tangled, messy web of custom code and high-maintenance connections. Every time you add a new tool or a new model, you're adding another fragile little thread to this web, making the whole system just incredibly brittle and a nightmare to manage. This is the integration chaos most of us are living in right now. This is what we call the N by M problem. And trust me, it is an absolute scalability nightmare. You've got N models needing custom hookups for M tools. What does that really mean? It means your engineers are doing redundant work, basically rebuilding the same integrations over and over. It means your code is so brittle it shatters with one minor API update. And for your users, a totally fragmented experience. This isn't just messy, it's like accumulating tech debt at an exponential rate.
But what if there was a better way, a standard way to fix this mess? A way to stop building these fragile, one-off connections, and instead create a truly interoperable ecosystem where any model could talk to any tool predictably and, more importantly, safely.
Okay, so let's get into it. This is the Model Context Protocol. Now, here is the most crucial thing to understand. MCP is a protocol. It is not a prescriptive SDK. It just defines a universal language, a set of rules for AI integration. And what that does is it forces all of us to adopt a spec-first mindset, where the clarity of the contract is so much more important than the convenience of a quick, one-off implementation.
The team at Anthropic really nailed it with this analogy. Just think about it. USB-C standardized how we connect all our physical gadgets. Well, MCP does the exact same thing for how AI connects to the digital world. It gives you that awesome plug-and-play feeling, but, and this is a big but, getting that kind of simplicity when you're operating at scale requires some serious engineering discipline.
And this slide really shows you that fundamental shift in thinking. On the left, you've got the old way, these brittle, custom-built connections that lock you into one specific model or vendor. But on the right, that's the whole point of MCP. You're creating portable, predictable tools that are designed from the ground up to be interoperable. You build a tool once to the standard, and it just works everywhere.
Architecturally, it's actually beautiful in its simplicity. It all starts in the host application, where your user's doing their work. An MCP client inside that app sends out a request. That request then travels over a standard transport layer, like HTTP, to an MCP server. And that server is just a lightweight wrapper that you build around a tool, like the GitHub API. The server does the work, sends a standardized response back. Simple, right? But incredibly powerful.
So here's the critical part. Connecting tools is one thing. Anyone can hack something together. But connecting them responsibly and reliably at scale, that is the real challenge. So let's walk through the best practices to take you from a basic prototype to a rock-solid, production-ready platform that entire teams can build upon.
Our first, and I would argue most important pillar, is this spec-first mindset. Before you write one single line of code, you have to define a strict, predictable contract for your tool. This makes sure every interaction is clearly defined so the tool behaves exactly as you expect it to every single time. Good contracts, people, they are the foundation of any reliable system.
This contract-first approach really comes down to 4 key steps. First, rigorous schemas. Don't be lazy and use generic strings for everything. Use strict types, use enums, use standard formats like ISO 861 for dates. Be crystal clear about what's required versus optional. Second, versioning. You have to adopt semantic versioning, SEMver, for all your tools. It makes your updates predictable. Third, have a deprecation plan. Don't just pull the rug out from under your users with breaking changes. And finally, and this one is non-negotiable, auto-generate your docs directly from your schemas. That's the only way to guarantee your documentation is never out of date.
All right, next up, we have to build our integrations to be secure by design. Security cannot be an afterthought. It can't be something you just bolt on at the end. It has to be a foundational, non-negotiable part of every single tool you expose to the world. So what does that look like in practice? It means having a full security and reliability checklist for every tool. You apply the principle of least privilege, so a tool can only do what it's explicitly supposed to do and nothing more. You always validate inputs and sanitize outputs to prevent attacks. You need robust authentication and authorization to control who can do what. And for reliability, you've got to use patterns like timeouts and retries with backoff for those little network blips, and circuit breakers to stop one failing service from cascading and taking down your entire system. And finally, make sure your requests are idempotent, so if a request gets sent twice, it doesn't accidentally create two of something.
And finally, you know the saying, if you can't measure it, you can't manage it. And that brings us to our third pillar, total observability and governance. You need to be able to see exactly what is happening across your entire system. That's how you define and enforce your service level objectives, or SLOs.
Now check this out. What's so powerful here is how we're bridging the gap between cold, hard data and, well, actual human responsibility. On one hand, you're tracking the technical stuff, right? Your P95 latency, making sure things are snappy, your error rates to catch any wobbly integrations. But then, and this is the magic part, you connect it to a RACI matrix, responsible, accountable, consulted, informed. You define clear ownership for every single tool. So what happens when the error rate for some tools suddenly spikes? There's no finger pointing, no confusion. Everyone knows exactly who is accountable for getting it fixed. That's how you turn a dashboard into decisive action.
When you follow these pillars, you naturally start to avoid the common anti-patterns. The absolute worst offender is the God tool, this single monolithic tool that tries to do way too much, making it impossible to secure or maintain. Another big one is using vague schemas, just generic string blobs everywhere. That violates Pillar 1 and leads to totally unpredictable behavior. And finally, please avoid tools with hidden side effects, like a tool that secretly sends an email when all the user wanted to do was read some data. Be explicit about what your tools do.
Look, adopting these standards, it isn't just some boring technical exercise to reduce risk. It's about unlocking this vibrant, composable, and rapidly growing ecosystem of interoperable AI tools that you, your team, and your users can all benefit from.
And the momentum here is just incredible. We're talking over 1,000 MCC servers already out there and available, and that number is exploding. This includes official tools from giants like GitHub and Stripe, plus just a ton of community contributions. This is not some theoretical standard anymore. It's a living, breathing reality that you can build on right now.
So why should you care about all this? Well, it means true portability. You build your tool sets once, following these best practices, and you can take them with you to any application that supports MCP. It means you get to leverage innovation from a huge marketplace instead of being forced to build everything yourself. And ultimately, this is the stuff that lets us build truly capable, autonomous AI agents that can securely and reliably interact with the world around them.
So that really brings us to a final, provocative thought. MCP isn't just another protocol on the pile. It represents a foundational shift, a move toward a future of composable AI. It's about tearing down the walled gardens and opening up a world of possibilities. So if any AI could securely use any tool, the only question left is, what would you build?